When considering lighting control for metal halide highbays in a warehouse, two primary options arise: lighting contactors and snap switches. Each has advantages and disadvantages that must be weighed against factors like cost, safety, and control requirements. Lighting contactors offer several key advantages. Firstly, they boast higher amperage capacity. This means a single contactor can handle larger lighting loads compared to individual snap switches. This is crucial for warehouses with numerous high-bay fixtures. Secondly, contactors facilitate relaying control signals. The lighting system can be operated from multiple locations, enhancing convenience and control. Thirdly, contactors enhance electrical safety. They provide isolation between the control circuit and the power circuit, minimizing the risk of electrical shock. Fourthly, lighting contactors support energy efficiency. They can be programmed to operate only when necessary, reducing energy consumption. This is especially beneficial in warehouses with occupancy sensors or automated lighting systems. On the other hand, snap switches also present certain advantages. Firstly, the initial cost is lower. Snap switches are generally less expensive than lighting contactors. Secondly, they offer simplicity. Snap switches are easy to install and operate, requiring minimal technical expertise. Thirdly, snap switches provide direct manual control over the lighting. This allows for manual operation in case of power outages or system failures. However, when choosing between lighting contactors and snap switches, several key considerations must be taken into account. Firstly, check building code requirements. Specific codes may dictate lighting control methods in warehouses. Secondly, determine the electrical load. Calculate the total amperage load of the highbays to ensure that the snap switches or contactors used have sufficient capacity. Thirdly, consider the desired control method. Lighting contactors offer more flexibility for remote, automated, or multi-location control than snap switches. Fourthly, assess reliability and maintenance. Lighting contactors generally have longer lifespans and require less maintenance than snap switches, although snap switches are easier to replace when they fail. Fifthly, perform a cost evaluation. Carefully weigh the cost of materials, installation, and ongoing maintenance for both options to determine the most cost-effective solution. When choosing between snap switches and lighting contactors, it's important to verify that the equipment chosen is suitable for the application. For snap switches, consider the ampacity and voltage rating, as well as the horsepower rating if the switches are to be used in other applications. Also, understand the different types of switches that are available, such as single-pole, double-pole, three-way and four-way switches. Confirm that any chosen switch is UL listed or has another similar certification. For lighting contactors, consider the number of poles and verify the voltage rating if the coil matches the control voltage that is used. Confirm the contactor has a UL listing or similar certification, and check the inversion sealed amps to ensure the circuit can handle it. Consider whether the contactor is mechanically held or electrically held, and whether the application requires a specific type. Mechanically held contactors use a latching mechanism to maintain their state, while electrically held contactors require continuous power to remain closed. A typical residential light switch is rated for 15 amps at 120 volts. Common industrial and commercial voltages are 208, 240, 277 and 480 volts. When wiring any lighting or receptacle circuits, follow all applicable NEC tables, guidelines and requirements. Article 210 covers branch circuits, which includes information on the number of outlets permitted on a circuit. Article 215 covers feeders, which is the circuit that goes from the main electrical panel to a subpanel. Article 220 covers branch circuit, feeder and service calculations. Article 230 covers services, which is the wiring coming from the utility to the building. Article 310.15 covers ampacity of conductors and gives direction for how to determine the correct wire size for a circuit. When running conduit, the NEC specifies the number of conductors permitted in a conduit. Chapter 9, Table 1 specifies the maximum percentage of conduit fill. Note 4 clarifies that equipment grounding conductors are not included when calculating conduit fill. Chapter 9, Table 5 provides the dimensions of different types of conduit. Chapter 9, Table 5 provides dimensions for compact aluminum conductors. Chapter 9, Table 8 specifies the number of conductors allowed in different sizes of conduit. When choosing the correct overcurrent protection for a circuit, it is important to choose the correct size based on the ampacity of the conductors and the equipment it supplies. Article 240.4 covers protection of conductors and explains how to choose the correct overcurrent protection. When installing electrical boxes, it is important to ensure that the box is sized correctly for the number of conductors it will contain. Article 314.16 covers the number of conductors in outlet, device, and junction boxes, and provides direction for how to calculate the minimum size box. Article 404.2 covers the number of switches allowed in an enclosure, and includes specifications for box sizing. Lighting contactors are generally considered the preferred option for controlling metal halide highbays in a warehouse due to their higher amperage capacity, enhanced safety, and greater control flexibility. However, if budget constraints are a significant concern and the electrical load is within the capacity of snap switches, then they may be a viable alternative. Always consult with a qualified electrical engineer to determine the best lighting control solution for a specific project and location. Consider the NEC influence on electrical installations and safety, particularly concerning conductor ampacity and overcurrent protection. For example, NEC Table 310.15 details allowable ampacities of insulated conductors, critical for selecting appropriately sized wiring. Overcurrent protection, such as circuit breakers and fuses, are sized according to NEC 240.4 to protect conductors from overload. The coordination of these elements ensures a safe and compliant electrical system. Furthermore, the NEC outlines specific requirements for lighting control systems in commercial and industrial settings. These requirements may include emergency lighting provisions, control panel specifications, and the use of listed equipment. Compliance with these standards ensures the reliability and safety of the lighting system. Always ensure that the lighting contactors and snap switches used are listed by a recognized testing laboratory such as UL to verify that they meet safety standards. A common lighting circuit in a commercial building may use number 12 AWG copper conductors, which have an ampacity of 20 amps according to NEC Table 310.15. A 20 amp circuit breaker would be used to protect this circuit. If the circuit is supplying lighting with a high inrush current, such as LED fixtures, a time delay fuse or high inrush circuit breaker may be required to prevent nuisance tripping. To determine the proper size for a conductor, start by determining the load. If a circuit will power 20 100-watt lights at 120 volts, the total wattage is 2000 watts. To determine the current, divide the wattage by the voltage. 2000 divided by 120 is 16.67 amps. Next, multiply the current by 1.25 to account for continuous loads. 16.67 multiplied by 1.25 is 20.84 amps. This means you must use a conductor with an ampacity of at least 20.84 amps. According to NEC Table 310.15, number 12 AWG copper conductors are rated for 20 amps, and number 10 AWG copper conductors are rated for 30 amps. In this case, you would need to use number 10 AWG conductors. Next, determine the correct size for the overcurrent protection. According to NEC Section 240.4, the overcurrent protection must be sized to protect the conductor. In this case, you would use a 20 amp circuit breaker or fuse. When installing lighting contactors, it is important to ensure that they are properly sized for the load they will be controlling. The contactor must have a voltage and current rating that is equal to or greater than the load. For example, if you are controlling a 480 volt 20 amp lighting circuit, you would need to use a contactor that is rated for at least 480 volts and 20 amps. It is also important to ensure that the contactor is properly wired and grounded. Follow the manufacturer's instructions for wiring the contactor and make sure that the ground wire is properly connected. The contactor should be installed in an enclosure that is rated for the environment in which it will be used. If the contactor is installed in a damp or wet location, the enclosure must be watertight. If the contactor is installed in a hazardous location, the enclosure must be explosion-proof.